Okay, so there are other ways to interrogate the circuit and find out the value of RTH. Now, this particular circuit is equivalent of this circuit here. Now, if we decide to short circuit this independent source, we draw a line here. And in the previous video clip, we showed how to inject a voltage source and measure the current Ix. In this particular segment, we are going to try a different method. And so basically what we're going to do is to inject a current like this. So this is the Thevenin equivalent circuit, and this would be the actual circuit. We're going to try to find out what Vx is. Now in this particular case, we can send in any current we like. So why not send 1 amp so that it's easier for us to figure out numerically the answer. We don't give ourselves any trouble. The first node, well, you can probably guess that we're going to use KCL and KVL. So we can do this on 2 nodes. On the red node, what we can do is to write the KCL where 1.5 I1 plus 1 amp has to be equal to the current running out of this 100 ohm resistor. So this is Vx divided minus V1. V1 is the voltage on node C divided by 100. A second independent linear equation that we can write is here on node C. So KCL on node C. Basically here, the current running in or out has to be equal to 0. So let's use the current running out. The current running out of the 200 ohm resistor is V1 divided by 200. The current running out of the 40 ohm resistor is V1 divided by 40. And the current running out of the 100 ohm resistor is 100 minus Vx divided by, it should be V1 minus Vx divided by 100 has to be equal to 0. All right. Now, actually, the previous method of using voltage source seems a little easier because in this particular case, Vx and V1 are completely entangled. If you remember from the previous segment, we can find out from one equation, V1. So, honestly, trying a voltage source is a little easier. But of course, we can finish this, and we know that I1 is equal to V1 divided by 200. So with these 3 equations, we can solve for whatever we want, and we're going to be able to find out that the voltage cut Vx would be exactly 177.8 volt. Therefore, RTH has to be equal to Vx divided by 1 and you know the